In this project, we developed a machine learning system to detect fraudulent credit card transactions. Fraud detection is not important problem because fraudulent activities can cause financial losses and reduce customer trust. The problem is treated as a supervised learning classification task where the model learns from labeled data to classify transactions as either normal or fraudulent. This project we use multiple machine learning models including logistic regression, random forest, decision tree, and support vector machine. The dataset used in this project is credit card fraud detection dataset from Kaggle. It contained a total of 284,807 transactions, out of which only 492 are fraudulent. This means the fraud cases represent only about 0.172% of data, making the dataset highly imbalanced. The dataset consists of numerical features. Most of features named V1 to V28 are generated using the technique called Principal Component Analysis, which is PCA, for confidential purposes. In addition, the dataset includes the amount feature, which represents the transaction values, and the class feature, which is the target variable. A value of 0 indicates a normal transaction and 1 indicates the fraudulent transaction. Since the dataset is highly imbalanced, special techniques are required to handle this issue and improve model performances.
Hello, I am Hasina Koshita. My primary responsibility for this project was data exploration and pre-processing. Then after uh, predicting by logistic regression, we use the credit card fraud detection dataset from Kaggle. It contains 284,807 transactions. The most critical observation during my exploration was the severe class imbalance. Only 492 transactions are fraudulent. That means 0.172 percentage as a percentage. This imbalance is why we couldn't rely on accuracy alone and instead focus on recall and ROC-AUC. Then pre-processing and featuring. Then to prepare the data, I first verified there were no missing values. Since features V1 through V28 were already PCA transformed, I applied standardization to the amount feature to bring it to a similar scale. I also removed the time feature as our analysis indicates it wasn't meaning for fraud prediction. I then split the data into an 80 to 20 ratio, ensuring the split was stratified to maintain the fraud percentage in both the training and training test sets. Then when addressing the imbalance with SMOTE, uh, because the model would struggle to learn from only 394 fraud classes in the training set, I implemented SMOTE, synthetic minority oversampling technique. This generated synthetic samples for the minority class, bringing the training set to a balance 227,451 cases for both classes. It is important to note that I only applied SMOTE to the training data. The test set remained unchanged to accurately reflect real-world conditions. Then implementation of logistic regression. I implemented logistic regression for this dataset. So initially the model achieved a recall of 0.92, meaning it caught 92% of fraud, but the precision was very low at 0.06. To improve this, I performed threshold tuning, moving the decision threshold to 0.9. This significantly improved precision while maintaining high recall. I also compared SMOTE against a class weight balanced approach, finding that class weighting provided even better precision, improving it to 0.25 and a superior F1 score. That's all. Thank you.
Our project focuses on detecting fraudulent credit card transaction using machine learning. We use a real-world dataset where each transaction is labeled as either fraudulent or non-fraudulent. Since fraud cases are very rare, the dataset is highly imbalanced, which makes the problem more challenging. As a group, we implemented 4 different machine learning algorithms and compared their performance. My responsibility was to implement and evaluate a random forest model. And my approach is, before training model, we performed an pre-processing in separate notebook. This includes scaling the amount feature, removing unnecessary features like time, splitting the dataset, and handling class imbalance like SMOTE. The processed datasets were saved in CSV files, which I directly used in my random forest notebook. And as you can see in the first cell, first I imported pandas library, which I use for handling and reading datasets. And in the second cell, here I pre-processed the training and testing dataset that were generated in pre-processing stage. The squeeze function is used to convert the target variable into one-dimensional format. In cell 3, this step is used to verify that the data has been loaded correctly and to check the distribution of the class. And in cell 4, here I initialize the random forest model with 100 decision trees. The random forest is an ensemble learning method that combines multiple decision trees to improve accuracy and reduce overfitting. Then I train model using resample training data. Here, after training, I use model to make predictions on unseen test dataset. I also calculate probability scores for evaluating metrics like ROC-AUC. And here I evaluate the model using multiple metrics. Okay, accuracy shows overall correctness, but since the data is imbalanced, it is not enough. So we use precision for accurate how accurate fraud predictions are, and recall how many fraud cases we correctly detected. F1 score balance between precision and recall, ROC-AUC overall model performance. In cell 7, random forest also provides a feature importance scores. This indicates which features contribute most to detection fraud. In here, finally, I visualize top important features to better understand the model's decision making. And in the results, actually, the model achieved a very high accuracy, around 99.9%. However, accuracy alone not sufficient for fraud detection. The recall for fraud detection was around 83%, meaning the model successfully detects most fraudulent transaction. The ROC-AUC scores was around 0.97, indicating excellent performance. Overall, random forest performed well due to its ability to handle complex patterns and reduce overfitting. In conclusion, random forest proved to be an effective model for this problem, especially due to its robustness and ability to handle imbalanced datasets when combined with SMOTE. Thank you.
For my part, I worked on the decision tree model for detecting fraudulent credit card transactions. Our dataset contains normal and fraudulent transactions, and the goal was to predict whether a transaction is fraud or not. Since this is a classification problem, decision tree was a suitable algorithm to try. I chose decision tree because it is easy to understand and easy to explain. Unlike some other models, we can actually visualize how to make decisions. It also works well for nonlinear patterns, which is useful in fraud detection. For this model, I used the proposed dataset prepared earlier in the project. The data had already been cleaned, the amount feature was scaled, the time feature was removed, the SMOTE was applied only to the training data to handle class imbalance. When building the model, I also tried to reduce off-fitting by controlling the tree depth and split conditions. I used max depth as 8, min samples split as 20, and min samples leaves as 10. This was done to make the model generalize better instead of just memorizing the training data. After the training model, I evaluated it using accuracy, precision, recall, F1 score, non-ROC-AUC. Because accuracy alone is not enough for this data set. The model gave an accuracy of 0.9765, precision of 0.0609, recall of 0.8776, F1 score of 0.1139, and ROC-AUC of 0.9474. The most important result here is the recall. The model detected 86 out of 98 fraud cases, which means it was able to catch most fraudulent transactions. That is useful because in fraud detection, missing fraud case is a serious problem. At the same time, precision was low, which means the model produced a lot of false positive. So even though it caught many fraud cases, it also encouraged fraud many normal transactions as fraud. I also checked feature importance, and the model showed that V14 was the most important feature, followed by V4 and V12. This helped us understand which variable had the biggest impact on the predictions. I also visualized the upper part of the tree, which made the model easier to explain. This is one of the main advantages of decision tree compared to more complex models. So overall, the decision tree model was helpful because it was interpretable and had high recall, but it still needs more tuning to reduce false positives. Compared to random forest, it is easy to explain, but it is also more likely to overfit. That was my contribution to the project.
I implemented a support vector machine, which is powerful algorithm that find the optimal boundary called hyperplane to separate normal transaction from fraud with the maximum possible margin. I used our preprocessed data, which has 454,902 training set and 56,962 test set. So the SVMs are computationally intensive. So we first experiment on sample of 10,000 data points to find the best kernel. In here, I compare two kernels, which are linear kernel and the Gaussian kernel. For the Gaussian kernel, I use three gamma values, which are 0.01, 0.1 and 1. For the linear kernel, I use three C values, which are 0.1, 1 and 10. So as you can see in the bar chart in here, The Gaussian kernel performs better than the linear kernel in terms of recall. In fraud detection, recall is very important because it measures how many fraudulent transactions are correctly identified. In here, the final model training, I selected a Gaussian kernel with C-value of 1 and gamma of 0.1 and training on a balanced subset of 20,000 samples. The final model achieved the accuracy around 0.995. So let's look at the metrics. So for the confusion matrix, we correctly catch 66 out of 98 fraud cases and correctly identified 56,587 normal transactions and only 277 normal transactions were flagged as false alarms. So in here, in the ROC curve, our ROC-AUC score is 0.973, which indicates very strong model performance in distinguishing between two classes. So, in conclusion, by combining SMOTE to handle imbalance and the Gaussian kernel to capture nonlinear patterns, I developed a highly effective SVM model for this project. In conclusion, we compared four machine learning models for credit card fraud detection, including logistic regression, decision tree, random forest, and support vector machine. Among all models, random forest achieved the best overall performance. It provides the highest accuracy and maintains a strong balance between precision and recall, make it more suitable model for real-world fraud detection. In logistic regression and the decision tree achieved high recall, meaning they were able to detect most fraudulent transactions. However, their precision was very low, which resulted in many false alarms. In SVM model showed strong performance in terms of accuracy and ROC-AUC, but hard but it had lower precision compared to random forest, indicating more false positive predictions. Overall, this project highlights that handle class imbalance and select the right evaluation metrics are critical for fraud detection. Machine learning models can effectively identify fraudulent transactions when combined with proper pre-processing and model selection techniques.